for warm-up, I'd like you to do this problem here. You'll notice that you start with $1,500 and you're going to show me the compound interest of 4.7% compounded annually. So remember that the following happens. P goes in the first column. In the next column, we're going to take P and we're going to times it by whatever the percentage is. Remember, we need to do that to 2 decimal places. And then we have to do a final total at the end, for which you just go A is equal to P plus the I, which is the information from the second column. Okay? All right. Good luck. Take care. All right. Some of you asked me to explain how I came to my solution. So here we go. So remember that we start with $1,500 in our investment, right? So then we're going to multiply by 0.0. Remember, it's 4.7%, which is 0.047. So we're literally going to take P and multiply by 0.047. And when we do that for 1,500, we end up with $70.50. Then we take those two numbers, add them together to get 1570.50. So now that you've got that, you're going to take that information and you're going to move it down to the next column, the start of the next year. So now we have 1570.50, and then we're going to times that by 0.047 to get 73.8 something with a number greater than 5, which is 81. Then we add these two numbers to be 1644.31, and so on. And now our bottom total ends up being 1,887.21. So now if we go and calculate the simple interest, we do the following. So for the simple interest, we know we're calculating I is equal to PRT, right? So we need I, we need P, we need R, and we need T from the original equation, and we're going to get P is 1,500, R is 0.047 for 1 year, and the number of years is 5 years, so T is equal to 5. So now all we have to do is calculate I. I is equal to PRT. To save space, I'm moving my calculations down. So we have this substitution. And then our final calculation for I will be, $352.50. So now, in order to compare what we've got between the simple interest and the compound interest, we have to total the simple interest with the original. So A is equal to P plus I, which is 1,500. Plus 352.50, which gives us 1,852.50. So that is our total for our simple interest. And you'll clearly see that the compound interest makes more money over time. Okay, all right. So now let's move on to our lesson for the day. Now, when we talk about compound interest, let's do a quick review of the information that we studied before.
we took a look at simple interest. Now, simple interest is basically interest paid on the starting amount, the principal of a loan. So imagine if we start here and we have a 10% increase. So what we do is we take that interest and we tack it onto the total amount of money, and we do that over and over and over again. So we end up with something that looks like a straight line. So please remember that when we're talking about simple interest, we're talking about a straight line. It only grows in a gradual progression. Now, when we talk about compound interest is similar to what we studied before. Y equals ab to the x, where the a value is the p, the b value is what we find in the bracket here, between here and here. That is what our b is, and we can guarantee that this b value is bigger than 1 consistently, so it's going to be growing. So if you think about it, imagine you had a bank account. You put your money in the bank account and the bank gives you interest daily. That money will grow over time if you do not change it. You just don't change the amount that you started with. So what happens is, as time goes on, the bank gives you more and more money, and then that money gets tacked on to more money, and then each time there's a new percentage increase, it's based on the previous amount. Now, let's talk about this basic equation we have here. A equals P 1 plus I to the N. What you're going to be doing is we're going to go and make sure that we understand what each of these variables mean. When we talk about the compound interest, A deals with the accumulated amount. You could also look at this as the future value or the final amount. When we talk about P, we're talking about the principal. When we're talking about that, we're really talking about the start or the A value in our equation for y equals a b to the x. Now, on to the variable I in our equation. I represents we're talking about the interest rate per compounding period, and we'll talk about that as time goes on. But you'll notice that if we put something that was in a compounding bank account, we have something that looks very familiar. You'll notice that, like before, we have our starting amount, and then it increases rapidly over time. And this is how much people make money in banks. They hope for compounded interest. Now let's talk about N. N represents the number of compounding periods. We usually take some composition of yearly time and multiply by a compounding factor. And we'll talk about that in the next part of this lesson. Now, let's go on to the ideas of compounding frequency terminology for I and N. So, when you talk about something that is compounding, compounding annually, we do nothing to that number. We either leave the rate alone or we leave the number of compounding periods, the N value, alone. Now, when we're talking about semi-annual, this means that the information compounds twice over an entire year. If it's quarterly, it's 4. If it's monthly, there are 12 times. Semi-monthly means there are 24 times. Bi-weekly, if you think about it, if we did weekly, it would be 52 weeks. But if we did bi-weekly, we essentially cut that in half and we end up with 26 times that happens in a year. Now, the main concept we're going to be taking a look at here are these two things. We take the I value. The I value is the rate or the percentage as a decimal divided by the compounding period that we choose. And then for the N, we take the number of years and multiply by the compounding period. So let's go and practice that right now. We need to be able to calculate or set up the fraction of the interest first, and then we'll figure out the number of compounding periods per period. Now, let's practice calculating the interest rate using the different terminology that we used before. So let's say I have something that is compounded semi-annually at 6%. Well, that's 0.06 is the percentage as a decimal, and then we divide by 12. Now, computing our number, we're going to get something like this. 0.005. Now, here is the deal. You have a choice of using this in your equation or this in your equation. Both can be used. I tend to use this in my equation in order to cut down on the lack of accuracy, because sometimes we end up having to round. Now 5% weekly looks like this. Now the 0.096 is an approximate representation of that number. Now what I would say to you is I would use this number for our calculation. Now I'm going to show you how you round it nicely. Let's say that the answer comes to 0.96153. What you need to look for is a high number like a 6 and a low number like a 1. And you use those two numbers to actually split this list here. And that will be our approximate number that we can use in our calculations. So I would say this could be used for our rounding purposes. The same thing can be done for quarterly when you have 5.2%. And we're done. Now let's move on to the last topic of the day before we get to our actual calculations. So something that is compounding periods. So we're going to take the years and we're going to multiply normally by the compounding period. So if I have something that is compounded quarterly for 5 years, I'm going to start with n is equal to, well, since it's already in years, all we're going to do is multiply 5, and we're going to multiply it by 4 to give our compounding number of 20. Now, for this other time period that we have here, we have something that's compounded semi-annually for 18 months. And what you want to do is you literally just want to say n is equal to, all right, it's 18 months. Semi-annually means half a year. If I took a look at those half years, I could say that happens every 6 months. So in that case, n is going to be, well, just 3 compounding periods. So this is every 6 months. And we take 18 and we try to find the number of blocks of 18. And it should be 3. Now, another way of looking at this is if I have something that is compounded in 18 months, 18 months is actually 1.5 years. And what we're going to do is we're going to take that 1.5 years and we're going to multiply it by 2 since it happens twice in 1 year. And that gives us an answer of n is equal to 3, which is what we expect. Now, you could have done this by taking n equaling 18 divided by 6 to give us an n value of 3 in that case. All right, now if I have something that's compounded bi-weekly for 6 months, in this case, what you're going to do is you're going to take n, and in order to get something that's done bi-weekly for 6 months, what we need to do is we need to take, well, take 6 over 12, which is 6 months, convert it into a year. Then what we do is we're going to times that by, well, you guessed it, 26, because bi-weekly means there's 26 periods throughout the year, which means our n value in this case is going to be 13, and we're done.
Okay, so remember that our basic equation for our compound interest is A is equal to P 1 plus I raised to the n. Now, we're going to use, since we're going to use this thing, when we go and do each problem, I want you to basically write APIN to kind of give us an idea of what each variable is in this problem, okay? Now, when we look at this, it says Jack borrowed $1,000, right? Compounded annually for 3 years, okay? How much did he owe in total? Okay, so in order to start this, you have to figure out how much we are starting with. In this case, we start with $1,000, right? Now, when we compound annually, right, it means annually means there's 1 year in 1 year, right? So what that means is when we take a look at this 5% being compounded, this I value is just 5% as a decimal, which is 0.05. And then you're going to divide it by 1, which gives us 0.05. And the reason why we did that is because when we compound annually, we're literally just dividing the rate by 1. You'll see what I mean by that later. Now, the next thing that we're going to do is we have to think of the number of years that has gone by. Now, the number of years in this case is 3, but because it's compounded annually, we have to take 3 and multiply by 1. And that gives us the total number of compounding periods, which in this case is 3. So now we take our basic equation that we have here. A is equal to P1 plus I to the n. And what we're going to do is we're literally going to go and take this basic equation and we're going to substitute what we have on the left side here. We do not know the A value, but we do know the P, the I, and the N. The P is 1,000. The I is 1 plus 0.05. Which is raised to the power of, well, n, which is 3. So we can simplify that because we know that a plus a number plus 1 plus that decimal 0.05 is just 1,000 times 1.05 raised to the 3. Now all you got to do is just put that into your calculator. Punch that in your calculator. Here's what happens. You end up with the final value being $1,157.63 because we are rounding to 2 decimal places. Okay? All right, so this is how you answer the final question.
So after 3 years, he's going to owe $1,153.73. So when we're trying to find out how much we owe, we have to compound that money. We have to build it up, but literally do it in one step instead of creating a table of values like we did in the previous lesson. And that's what we get for our final answer. So now let's go and take a look at example number 2. Example number 2 has Barbara, who invested $2,500 at 6% compounded semi-annually, okay? When you have something that compounds semi-annually, right? The compounded part on here tells us that we have to use that A equals P1 plus I to the n calculation, that equation that I gave you at the beginning, okay? Now, we're going to have to use that, and because of that, we have to set up our APIN. And that is just to kind of give us an idea of what all the givens are. You don't know what the final amount is, but you do know what the initial amount is. In this case, we got $2,500, right? So it says Barbara invests $2,500 at 6% compounded semi-annually. Now, the word semi-annual means that there are 2 times in a year where this thing happens, okay? So remember that 0.06? So 6% can be written as 0.06. Then what we do is we take that percentage and we divide by the number 2 that represents the semi-annual amount of time something compounds, okay? Now, it says we're doing this for exactly 4 years. So because this is happening for 4 years, and it says we're trying to find out how much we have at the end of the investment, that is what this equation is for. So now, because, remember, it said it was 4 years, we have to take 4, and then what we're doing is we're going to multiply it by, you guessed it, the number 2. So 4 years times 2. And just remember, that 2 represents the compounding semi-annually. So that compounding semi-annually happens that way. Now, we just take our basic equation with all this information and we simplify as much as we can. So the 0.06 is supposed to be divided by 2 is 0.03. We're going to use that in our equation, and 4 times 2 gives us 8 compounding periods. So what we end up with is this for our equation. We start by writing our equation, and then we substitute accordingly. So we're going to put P as our starting value, which is 2,500. Then we go 1 plus 0.03 raised to the 8. Okay, and we can simplify that for when we go and put it into our calculator. 2,500 times 1.03 raised to the 8. Now, punch that in your calculator, and you're going to get your A value, your final amount being $3,166.92 as your final answer. So they ask you, how much did she have in the end? So after 4 years, oh boy, I can't write today. So after 4 years, she has $3,166.92. And that's it. That's how we answer that question. Now, the next question you should ask is, how much does she earn in her investment? Here's how you calculate interest. Interest is just basically the amount that we have at the end minus the original principal. So in this case, we're going to go right $3,166.92 minus $2,500.
which gives us a final answer of $666.92. And that is what our interest is. So if you wanted, you could write, yes, therefore, the interest she earned is $666.92. And so now let's move on to the final question of the day. Frank borrowed $3,600 at 4.8%, right? And what we're trying to find out is how much he owes at the end of his term for his borrowing, okay? So we don't know what the A value is. So it says he borrows $3,600. So the principal is $3,600, right? And we compound quarterly for 6 years. So we compound 4.8% for 6 years. So remember, 4.8% is 0.048, but then we're compounding quarterly. So remember, quarterly means the number of times it happens in a year is 4 times a year. So we're going to divide 0.048 divided by 4, which gives us a final answer of 0.012. Okay, now N is the number of years times that compounding number, which is that 4 number. So we're going to times it by 4, which gives us 24. So now our basic equation is this. And the reason why it's A is equal to P1 plus I to the N is because we want to know how much do we owe at the end of the loan. So when the loan comes due. All right. So we're just going to substitute what we know. We have A, P, and IN. So let's do that. So A, we don't know what it is. So we just put A. And then 3,600. And then 1 plus 0.12. And then we're going to raise that to the power of 24. Well, in order to make our calculations easier on the calculator, I'm just going to rewrite this as 3,600 times 1. Let's make a correction to the previous line. So on the previous line, we should have 0.012 and then 1.012 raised to the 24. Punching that into your calculator, you're going to get A is equal to, ready, $4,973.30. So that's how much we owe at the end of the loan, right? But it says, how much did he owe in interest at the end of the loan? Remember, the interest is equal to the amount minus the principal. So the amount is $4,973.30 minus the principal, which is $3,600. So that means our I value, the interest, is going to be the following number, $1,193.30. All right, so there's your homework. You're doing 432, 139, and 12. So just remember, when you're trying to find the interest, you have to find the amount that you owe at the end minus the amount that you owe at the beginning. And that's why we have the 4,793 minus 3,600 to give us our final answer for our interest, being 1,193.30. Make sure you clearly identify those things on your worksheet.